Hello and welcome to our webinar, Using AI to Enhance Business Operations. I'm Paul Michelman, Editor-in-Chief of MIT Sloan Management Review, and I'll be your moderator today. This event will be recorded and will be available to all attendees approximately 3 to 4 business days after the end of the live event. In addition, today's slides will be made available to all attendees. We welcome your questions for our speaker today. To submit questions, please enter them anytime in the question module on the GoToWebinar control panel, or you can submit questions on Twitter using the hashtag #MITSMREvent. We'll answer as many questions as time permits. If you are having audio difficulties while listening on the computer, please sign out of the webinar and sign in again, or check the help link in the upper part of your console. Our speaker today is Monideepa Tarafdar, Professor of Information Systems and Co-Director of the Center for Technological Futures at Lancaster University Management School. Our thanks go out to Bold360 by LogMeIn for their sponsorship of this webinar. Monideepa, over to you.
Thank you, Paul. So today we're going to talk about how we enhance business operations using artificial intelligence. This is based on a forthcoming paper in the Sloan Management Review next month, and co-written with Cynthia Beath at University of Texas at Austin and Jeannie Ross at MIT Sloan Scissor. So let's begin by looking at the two ways in which companies and people can benefit from AI. The first way is that you embed AI or learning algorithms into products, and we know that such products include telephones, Alexa, self-driving cars, Duolingo, where everything that we seem to put in the machine learns and changes its outputs, and that's how it operates. The second way, which we will focus on now, is the use of machine learning to improve business processes. Now, by business processes, I mean things like customer service processes, loan approval processes, and things like where the computer is trying to identify patterns in data. Now, let's see how that works. And we call this enterprise cognitive computing, or ECC. What happens in such a process is that first you have a bank of data, and then from that data, you feed that data into an artificial intelligence algorithm. It's an algorithm that uses things like machine learning, neural networks, Bayesian statistics, inferential patterns, all of that stuff. That works on the data that you give it, and it identifies patterns. Now, if you give it business data, it will identify patterns from the data, and that can form the basis of business rules. For example, it could come back and say, we've looked at your customer data for the last 10 years, and we see that customers with characteristics A, B, C, and D are 90% likely to pay loans on time. That's what your data shows. Now, if that pattern looks like something useful, that enterprise cognitive computing application that is taking that algorithm's output, that gets embedded into a business process for, let's say, loans approval. And so the person who's approving the loans, he or she looks at the output that says customers with characteristics A, B, C, and D are 90% likely to pay loans on time. And then what that person does is takes that output and makes a decision based for a given customer, right? So that's how the enterprise cognitive computing application works. Let's just go over and look at an example. So what we are doing here is let's look at a call center process. So we have a person who's calling the call center, right? And there you have an ECC application. It could be a cognitive agent. It could be someone who speaks to the customer in a human voice. And that application knows the automated rules. So for example, it knows what kind of faults the customer might ask about, what certain faults mean. So for example, let's say the customer says, my screen is blue. So let's say this is a call center for tech support at some company, and the customer says, my screen is blue. So what the ECC application will then do is to say, okay, what does blue screen mean? It works through its AI logic and it comes back with a response to the customer, let's say 90% of the time, right? And in that way, what happens is 90% of the time you can get a query resolved within, let's say, 5 seconds on a 24/7, 365 basis. The rest of the 5%, what the ECC application does is to transfer the call to a human agent because it couldn't figure out what to do. It was an exception. And the human agent then runs a business process. It queries the database, it talks to the customer, he or she talks to the customer, and then gets back to the customer with the problem resolved. So what you're doing here is you are using all of that data that is fed into the ECC algorithm to search better, to reduce the search time, go through lots and lots of fault information and fault history, and come up with consistent and accurate data inputs. That's what the business is doing at the level of the ECC application, right? Now, in doing all of that, what the ECC application is doing is identifying complex patterns. Now, if those complex patterns make sense, then what happens is that they can be used to make business rules. For example, if there is a pattern which says in that ECC application we just saw for the customer fault resolution, if there is a consistent pattern which says blue screen means there is an issue with the boot up and the customer has to reboot the machine, right? So then if that is a consistent pattern, then that can get baked into an automatic business rule. And so the ECC application then automatically suggests that to the customer. What that then does is to free the human for the more complicated tasks, right? For example, if the ECC application goes through a ton of different workflows and still is not able to resolve the process, then the ECC, the agent can then use that input to resolve the more complicated problems. So in sum, then what happens is the repetitive and the formulaic tasks, which can be easily sorted, they get automated in the application, freeing the human for tasks needing adaptivity and creativity. So to give an example, another example, let's say from a loan approval process, if you have a lot of loan applications which are pretty standard, like you have standard people, standard income, and then the ECC application for the loan approval process then can say, okay, if this is 90%, if this customer looks like he or she is 90% likely to pay the loan, we won't go back to the human loan approver. We will approve that at the level of the ECC application itself because we know that these are standard customers. But then, for example, then if you come across a customer who, let's say, is an expat from one country to the other, they have all of the, they make good money, they have, they have a steady job and all of that, but they don't have, let's say, a credit history in the new country. Now that is an exceptional case. And so the ECC application may not be able to solve that and pass that on to the human loan approval, the person who's doing the loan approval. So what we are trying to say here is that good ECC application cases are those cases where you have lots of, they can search a lot of data, produce consistent and accurate data inputs, can identify complex patterns, and those tasks which are repetitive and formulaic are very well suited to these kinds of applications, while the more exceptional tasks can be then passed on to the humans to be more adaptive and creative. So that's the benefit of enterprise cognitive computing when you embed AI in business processes. We have a poll here, and
yeah, we should, folks, you should be seeing in just a moment a poll screen come up. There it is. Please take a moment to weigh in with your thoughts on this question. In your organization's AI efforts, what has been the hardest to do? keep it up for just a little bit more. Okay. So Monideepa, I don't know, I believe you can't see the results of the poll, but I can. Care to make a prediction before I read them?
I think it's either 4 or 5.
Very good. So I'll read them from lowest to highest. Again, in your organization's AI efforts, what has been the hardest to do? The fewest people said getting the right people, 6%, followed by change processes, 17%, get the data, 22%, identify tangible business results, 24%, and at 32%, number 5, which is one of the ones you predicted, change the way people think about and use data. So what's your interpretation there?
So here, what we found in our research poll is that organizations' approach to AI goes along two very dichotomous, opposite kind of on the end of the spectrum. So there's some who think that I've seen this, this is nothing great, we've got AI winters, and what's new? That's extreme skepticism. And on the other end, that's the thing that, okay, this is going to change everything. It's going to solve all the business problems, take care of all the problematic business processes. It's magic, right? And so I think 5, and that is something that we have seen, across companies, across sectors. There are extreme views and reactions to AI, and none of those views are quite accurate. And I think the fact that we have most people saying 5 is the hardest to do reflects that we need to change the way people think about and use data, because that is what feeds into AI. So let's look at how that can be done. I'm glad we did this poll at this point. In our research, and this is one of the reasons why we undertook this research, because we saw that while everybody was optimistic about the potential for change that AI can bring in business processes, we found very few people who really knew what it took to do that. And to understand that, we undertook this research, and we found 2 sets of findings, and I'll go through them one by one. The first set of finding was that there's some capabilities, organizational capabilities, we'll call them ECC capabilities, that organizations need to develop in order to get value from AI. And I'll go over them. And the first, of course, should not come as a surprise, because you had that people data, and so let's look at this. So data science competence essentially means that you have people who have your organization has the statistical and computational skills to work with data. They know that there is knowledge of how to acquire the data, convert the data. There's a lot of tools out there that work on data, open source tools and also proprietary tools, knowing what tools to use, because there's absolutely a plethora of tools available. So what is fit for purpose, what should work in a particular organization or process. So that's another thing that data science means. Top-notch data scientists also have so statistical and computational tools. Again, there's lots of them. You hear things like natural language processing, knowledge representation, statistical inference, learning algorithms. So all of this morass of technical complexity that there is, the data science competence cuts through that morass and clearly comes out with, this is what we need to do, this is what our business needs, these are the tools we will use, these are the skills we need, and so that's what it is. And as many companies have discovered, it's an expensive competence to hire. And we've seen companies who've freed up operational level IT skills through good automation of operational backbone, and then freed up the money to find good data science skills. We've seen companies which have dedicated, so they've started building data science teams, deliberately building, putting in the resources, hiring one person who's got strong competence, and then letting that person build a good team of data science people. So data science competence, obviously, because we're talking about data feeding into an AI algorithm, is very important. The second one is what we call as the business domain proficiency. So this is having the right data science skills is not enough. This is what business domain proficiency is, what links the data science competence to business value, which means that you have people who understand the processes. They haven't, so if they have an understanding, so for example, if we are looking at an ECC application for a call center process like we just discussed, they have an understanding of the tasks which are involved in the process, who is doing what, all of the other processes that, the different functions that feed into the call center. So for example, you may have customer support, you may have marketing, you may have, internal, customer satisfaction team. So all of the different functions which feed into the process. Then, what does the data mean in terms of the process? How does the data, understand? So a data scientist will understand the data as an entry in a table. A business domain person will look at that data and say, this is what it means in the context of the business. So that translation is very important. And that is what comes from business domain proficiency. For example, we had a pharmaceutical company, and they were describing to us the complications in business, how difficult it is. And they said, look, a big part of, of being a diabetic is, sometimes you're obese. So should there be an obesity dimension in the ontology of diabetes? Or should diabetes be an attribute of obesity? And of course, people who've got, they're overweight also have, joint replacement problems. So, should all of them go together? And then they also have depression. So data ontologies can get very complicated, and the understanding of how data elements link to one another and how do they link in the bigger picture of the process is another part of business domain proficiency. The third competence that we came across we found that was enterprise architecture expertise. Now, what happens is that ECC applications can deliver value only when you place them in a bundle of changes, which means changes in processes, and they change policies, they change practices. So in order to make an ECC application valuable or used, there are things that need to be done, such as business processes have to be rationalized. We know that from many years ago, which means changes in jobs, changes in jobs, skills, new roles, so upskilling and reskilling need to be done. So a big chunk of organizational change has to be done for most ECC applications, because most ambitious applications, they affect different processes, not just one process. So enterprise architects are needed to orchestrate all these changes in roles, changes in jobs, changes in tasks, changes in how they link to one another. And of course, we can see that an enterprise architect needs a huge breadth of skills. And to give you a couple of examples of the kind of skills needed, in one of the companies that we studied, prior to implementing a help desk application, they had to rationalize the process because they had a number of help desk applications, many of them. So what they did was get it down from, so they rationalized, they reduced the number of help desks from something like 3,000 to something like 2,000 before they even attempted to build the application. So process rationalization is an example of enterprise architecture. Another example of enterprise architecture is the creation of new roles. So we had another example where we had an ECC application telling sales experts or suggesting to sales experts, how they should go about approaching customers. And it turned out that sales experts had to do more cold calling than they were used to. And so a new role was developed, that of a coach. And what the coach went and did was to coach the experts, the sales experts who were using the ECC application, in how to approach customers. So things like that are necessary in order for ECC to deliver value. And good enterprise architects come from a number of places. They are hard to find, but they are usually people who are steeped in organizational design and change management, business leaders who are used to managing large technology-driven change projects, or human resource, senior HR people who've seen, a number of roles, who are experienced in designing roles, new roles, and across different functions. Occasionally, you also have IT professionals who have exposure to many different departments. They know how things work, who knows what, and how things link. So enterprise architecture expertise, therefore, is a difficult capability, but it's an important one. The fourth one is, of course, the operational IT backbone that you have. So ECC applications are never, ever implemented in isolation from the rest of they're not usually implemented in isolation from the rest of the infrastructure of the company. In any case, you need access to data, which is there in databases, which already exist. You need standards, for security. You need to connect to the network. You should have APIs, gateways, all of the infrastructure that you need for ECC. It's present in the operational IT backbone. So companies which have a sophisticated IT backbone, which means that they have rationalized business processes, they have, database, good quality data, they have, the database architecture that's needed, they have an architected IT platform. Those are the things that are needed for ECC applications to be inserted into the infrastructure. For example, we had an example where an application, the sales application that I just mentioned, it was actually embedded in an existing CRM system because it had to draw customer information, for example, their demographics and things like that. And that could only happen when it could link to the existing CRM system. So an operational IT backbone is therefore an important capability. Also, when we put ECC applications into production, we need access to data, we need access to the overall the standards, and there also the IT backbone is important. And the last one is what we call as digital inquisitiveness. And this speaks very clearly to the poll that we had, where we said we need to change the way people think about data, right? And what we mean by digital inquisitiveness is the following. What happens is that ECC applications do not give you a definitive answer. They're not going to say 2 + 2 = 4. They are going to say, this is the probability that 2 + 2 = 4, or this is the probability that someone's going to make a purchase, or this is the probability that this patient has this disease. And so what the human has to do is to take that probabilistic answer and decide what to do with it, the organization or the human. So this is what we mean by data-driven decision making. And so what we mean by digital inquisitiveness is a constant willingness to grapple with these outputs and to question them and to work with them and to see how they can improve the work processes. So questioning and evaluating outputs of ECC applications is very important. Now, this speaks to what I said, when we had the poll. So there is this extreme view of skepticism and the other view of magic, and neither of this is true. And the bridge that the thing that bridges them, I think, is the digital inquisitiveness. If you look at the data in a proper perspective, then that's easier to make a good decision based on the data. So digital inquisitiveness then means, using the ECC outputs to improve the work processes, to figure out how you can do things differently or better. Curiosity about, what it is that's going on. I'm not saying everybody has to be a data scientist or every manager has to understand exactly what's going on. It doesn't have to be an AI expert, but just an understanding of what's going on and how it's happening and what it is that the data is telling me is very important. So let's have another poll.
Great. The poll screen, folks, should be up now, and you're answering or giving your opinion on in which capability is your organization the furthest along. And we'll have the poll up for just about a minute, so please jump in. All right, folks, we'll be closing it out in just a second. Okay, Monideepa, here are the results. Again, I'll start from lowest to highest. In which capability is your organization the furthest along? 13% say digital inquisitiveness. 14% responded with business architecture expertise. 19% said data science. 25% said operational information technology backbone, and 29% noted domain expertise.
What was the percentage for business architecture expertise?
14%. So that was down there with digital inquisitiveness as the lowest.
I think that's very consistent with our first poll, right? Where they said that, where everybody said that number 4, the way you think about data. So I think this is in a way this is great because it reflects a good degree of consistency between what we had the first time. Now, in our research, we found that business architecture expertise was one of the most difficult things to do because of the breadth of expertise and talent that it needs. And regarding the operational backbone, yes, so many of us are familiar with the literature that's come out of CISA on the operational backbone, and we do know that there's a lot of companies out there which have now an operational backbone. And so they're beginning to get that, and so that's not surprising either. Domain expertise, yes, because most people who work in functions, they are experts in that function. They have worked there for a long time. So this is totally in line with what we expected and what we saw in our research, which is good because now we can figure out what to do about it. So one thing that we did was when we looked at the capabilities, there are 5 different capabilities, right? But then when we saw what organizations were doing with that capability, we found out that you have to kind of meld them. You can't just have the capabilities in isolation. And the melding of those capabilities happens through 4 practices, which use those capabilities to do certain things. So let's get to that. And that will speak to the results of the poll also. So the second set of foundational issues of foundations of ECC competence is what we call as ECC practices, and we had 4. We found that there were 4 of them, and each of those practices took those capabilities and combined them in different ways. So the first one is every successful implementation or most successful implementations that we saw were based on a clear and realistic use cases. So in the first poll, we had a question which said, how easy is it to identify tangible benefits from AI? And I think it was one of those which was not very high, right? And we did find that it's hard to visualize what it is that AI can do for the business process. And the way to get started on that is to develop a use case. And what the use case does is address, so it attacks a pain point. So so let's say you have a problem which says, my help desk turnaround is 5 days. And, the percentage of queries resolved in the first point of contact is 50%. That's clearly a problem. That's a problem in a process. So a use case is based on a business problem. It gives you a description of what the application is going to do to solve that problem or to address that problem. Who is going to be using it? How are they going to be using the outputs? What data is going to be needed? What is the actual algorithm that's going to happen and that's going to work on the data? And it is so it really covers the the gamut of the issues that would be needed in that people would face in an ECC application. And obviously you need domain experts because they need to identify the business problem. You need the data scientists there because they need to figure out what the algorithm will be. You need to let the users interact with the ECC application. So you need IT folks to develop the application. You need enterprise architects to visualize what kind of roles, how roles would change or how skills would change and things like that. And one thing we found out was that having realistic use cases which demonstrate quick value. So if there's a particular pressing issue that a large part of the company faces, or an important part of the company faces, it makes sense to develop a use case around that. And if that works, if the ECC application works, you can demonstrate very quick value, and then that serves as a sort of sounding board for further ECC applications, a launching pad. So it gives a good sort of start. And the other thing that we found was that use cases can be reused. So for example, if you have a use case that looks at text mining we had a pharmaceutical company where they developed a use case where they were text mining patent data for a particular disease. And they developed a use case based on that. They developed the ECC application. What they found out was that they could reuse that for other diseases and text mining patents for other diseases. So use cases serve a lot of purposes, different purposes. The second one was we found out that, this is machine. So we talk a lot about machine learning and learning and how the phone learns. So obviously then how does the ECC application learn was the question that many of our, places where we did the research they faced. So what happens is business conditions change, and people's preferences change, economic conditions change, political conditions change, and so over time what happens is that the application data that we use to initially train the application, develop the application, becomes a less and less accurate reflection of the reality. And then what happens is the application needs to be retrained. Now that can happen in a number of ways. So what we found out that some companies, they kind of embedded in the application the ability to report what was going on. So self-report, when the model was drifting or it was going beyond the error parameters that were being specified, or users were not satisfied with the outputs. And so these are all indications that the application has started to drift. And so monitoring that model drift and then coming back to say, okay, we need to retrain this. Maybe we need to get more data, or we need to get, we need to have a different set of business rules, or we need to have new domain experts, or we need to maybe apply a different sort of algorithm or a new. So those sorts of things then come into the training of the application. ECC applications, we found, do not learn automatically because of the complex architecture and infrastructure in which they are embedded. It is not like the phone, which kind of takes your input and then automatically learns the words you write or what words you write together. These are complicated applications which need many, many different data inputs. The acquisition of that cannot be automated. And so learning happens on a supervised basis. It happens when people get their heads together, when data scientists and domain experts and IT folks, they sit together and say, yeah, this is drifting in this way, it's not working. And then so what's the reason? Is it because people's preferences have changed, or is it because our infrastructure has deteriorated, or is it because something else? So those reasons have to be found out, and then the application gets retrained. Usually it's a case of the data becoming less and less an accurate reflection of reality because things have changed. So it's a team-based effort, and it is one of the most important things that companies do once the ECC application is in production. You keep monitoring it, and then you have to retrain it. The third one that we found, the third practice that companies used was co-creation. Now, co-creation is a very, it's not a new concept to most of us. So we tried to understand what it is about co-creation and ECC that's different. And what we found out was that co-creation was not just needed for developing the application, which of course it was, because as we said, you need different expertise to come together, different sorts of expertise to come together. Co-creation was also needed throughout the life cycle. So development, then you put it in production, and so you need the IT expertise to make sure it's properly working. And then you also need it throughout, training and retraining. So as long as the ECC application was being used in the business process and its outputs were being used to make decisions, we needed co-creation, meaning different people had to work together and do what was needed. Co-creation also serves to develop shared responsibility. So it's not like, okay, the data scientists are responsible, or the domain experts are responsible, or the process people, or the users. It's everybody who's responsible. It helps to build that idea. It also helps people to learn from one another, because the domain of ECC is still very complex. People don't understand. One person or two people don't. It's not possible for one or two people to have the whole picture, because there are so many different things involved. So co-creation helps people work with each other, meld the expertise of different people throughout the life cycle of the ECC application. This is different from the regular co-creation that we see in much of it that we see in regular software development. And finally, and again, this speaks to the the poll, clarify expectations around ECC. What can it do? What can't it do? What is it good at doing? What is it not good at doing? And of course, it's not magic. It's a lot of hard work. So those sorts of expectations, once they are clarified, it's possible for companies, then to create a very positive buzz and excitement around, thinking cognitive. Many companies we talked to, they said, no, this is not something which we see as a gloom and doom situation. It's something we should see as an application or an approach that empowers people to focus on the more creative tasks and be excited about their job, and use it as a means to figure out how they can improve what they're doing. And there's different ways to do this practice. And one of the things we saw was champions was important, to recruit and train and reward champions, and to give you a flavor, to give everybody a flavor of what think cognitive means. It could range from something as simple as a lunch. So one of the applications that we studied got started over a business lunch between a data scientist and a senior leader in one of the domains, and they started talking. The domain expert was the business leader was talking about a problem that she had, and the domain expert said, hey, you know what, I think we can have a go at that. And so that became the seed point of a very successful ECC application, and then that was kind of took on. It could also come through crowdsourcing. Some companies we saw, they literally had suggestion boxes. Remember the old time suggestion boxes, but this was an electronic suggestion box, which was basically crowdsourcing ideas. How can your job improve? How can you improve your job by inserting ECC into it? Which parts can you automate? Which parts are boring? Which parts are more interesting? Then there's some other organizations said, we have our data scientists go to different parts of the company, because data science is still something of a, it's still seen something as a technical thing. It is a technical thing, but many business leaders don't understand or don't really realize what data science can do for them. So seminars, conferences where data science experts go into the business domains and talk about what they can do, what problems they can solve, that helps. And champions, domain experts make very good champions. IT folks who've solved, who've been through big business and big change implementations can make very good champions. But we mostly found out that domain experts make very good champions, because they can match the data science or the AI competence with specific business problems that they make. So we had in one company, we had domain experts who wanted to champion, or who recruited champion ECC. They did walkabouts in different departments and talked to people. And so a mix of all of these things can propel these practices mix of all these practices can propel this thinking cognitive process that we looked at. So we have another poll.
Okay, folks, once again, a poll screen should be showing up in just a second. This will be our third and final poll. With respect to ECC applications, which of the following applies to your organization? You can read the list and please weigh in. We'll have this up for about 40 more seconds. Okay, here are the results. Monideepa, I'll do it from lowest to highest once again. The fewest respondents selected our ECC apps have self-reporting error alerts, 7%, followed by we have an ECC app training strategy, 10%. Our data scientists train and retrain our ECC apps, 23%. Our IT experts train and retrain our ECC apps, 27%. And a cross-functional team manages how our ECC apps are trained, 34%. Seems like generally good news.
Yes, so with respect to who is training the applications is very good news. But notice that only 10% said we have an application training strategy, right? So again, I think this is this is what we also found. This is symptomatic of the fact that we're still grappling with the realities of ECC, right? So once you develop, probably developing is easier than implementing, is easier than using, and is easier than and maintaining and training. And in this case, maintaining ECC applications essentially means training. So that's I think it's consistent with what we saw in our research as well. So training was something which was problematic. I think cognitive champions. We did have companies which had champions. We did have companies which had the other practices. But yeah, training was it's a bit of a red herring, because you immediately get into the conversation about supervised and unsupervised learning, but that's really not the focus. That should not be the focus. The focus should be, okay, how are you training and retaining? Because once you implement an ECC application, you know that it has to be supervised. Then what the final thought that we had was, it's good to learn by doing. And so companies that we found out were the most successful, they had this virtuous cycle going in, meaning that you let the capabilities, once you use the capabilities to execute the practices, then you get better at the capabilities themselves. So for example, if one company we looked at, over time, we looked at what they did over time, and we asked them, how did you start and what happened next and what happened next? They started off with a very small, by small I mean not a very big ambitious application, but one application that addressed a clear problem. And they recruited, not recruited externally, but they made a cross-functional team with people who were, digitally inquisitive, and they wanted to solve the problem, and they got a data scientist and domain expertise, so those three components, and they developed a use case, right? And then the use case, they took hold, and then the use case led to more people getting interested in what was going on. And when the first application was implemented, because it was co-created with a lot of different people, it took off, and then that little application, which really addressed an important problem, started getting talked about. And once that started getting talked about, more and more people started getting interested in okay, what is this thing? What is this? What is ECC? Can we learn more about it? Can we look at our own processes and see how it works? And so we found out that the capabilities started getting developed because people started getting more inquisitive. they started developing an understanding of what are the changes which are needed. So business architecture expertise became became stronger. Data scientists also understood, okay, this is how how we apply our methods to the business problems, and that in turn again led to more use cases and more co-creation, more thinking positive. And so this learning by doing virtuous cycle is something that we found very interesting. So I will leave the audience with this thought, and then we can take questions now.
Monideepa, thank you very much. So let's move into our Q&A, and we have got quite a few questions, and we'll continue to take your questions for the remainder of the hour. A reminder that you can submit your questions by entering them into the questions module or on Twitter using the hashtag #MITSMRevent. So Monideepa, let's dive right in. There have been a number of questions, kind of on the level of strategy, because enterprise cognitive computing, or AI, are not a strategy in and of themselves, but successful implementation of them requires this kind of broad set of often new capabilities that you point out that feel very strategic. So how are organizations connecting ECC to business strategy, and how do you avoid the cart leading the horse?
Yes, so this is a question that we faced with IT applications for a long time, right? So when we say that business domain expertise is something that understands what the problems are, right? So if your strategy, in one of the studies we did, we found out that ECC applications can be applied towards customer experience or operational excellence, and to the extent that these things are linked to the organization strategy. If your strategy, companies lead through different strategies. So they could be customer focused, or they could be operationally excellent, or they could be differentiation based. So it's the business domain expertise that links these strategic imperatives to specific business processes that can be improved, and then that gets linked with the data science expertise to say this can be improved with ECC. You see what I'm saying? So the capabilities themselves, when you put them together, they give you those important pain points that link to the organization strategy. So business domain expertise, I think, is the main thing that links ECC to business value, and then that kind of links to the others.
Thank you. So a number of people have asked questions about kind of making the case for the cost of implementation, because when you factor in all the costs, kind of real costs, skill costs, the cost of training, it can be hard to support, right, with a traditional business case. So how do organizations that haven't taken the first step, right, how do you get beyond this issue? Do you need a burning platform?
Yes, so of course, some organizations are better positioned to take advantage of ECC. Let's face that. If you don't have an operational IT backbone, it's hard for you to say, let's go and do AI. It's a step-by-step process. It's not a moonshot process. Number one. Number two is assuming you have the data, assuming you have some of these, the infrastructure in place. We found out that quick use cases which solve current and burning business problems, they serve as a good platform to launch subsequent ECCs. And time again, we saw that ECC is not a moonshot. It's not a one thing that you do like a grand thing. It's little steps, one at a time. And the reason why we talk about capabilities is that if you don't have these capabilities, you better start developing them, because without them, you can't go from the first step to the last step in one shot. It doesn't happen. With ECC, it doesn't happen. You have to have the data, you have to have the operational backbone, and then you don't have to have them in, some companies don't have every capability in equal measure, but as long as you have some of them, you can bootstrap. It's a bootstrapping process. And getting hold of clear use cases, realistic use cases, getting hold of a small bunch of people who are interested in doing this, getting hold of data scientists who are willing to talk to the domain experts. Sometimes it's how do I say, improvisation, but these capabilities should be there, and it's not something which if there is a yeah, of course resources is an issue, but starting small, showing quick gains is a way to address that problem.
Thank you. So thinking about capabilities, in your research, what have you found are the toughest required capabilities to acquire or to develop?
Okay, so what we found out, so people think that a lot of people, many applications we studied, everybody thought that, okay, this is a data science problem. So we need, really good data scientists. But ECC actually handles business problems. And so the revelation was for many of the companies was that the technical capabilities, although they are important, that's not really, that alone doesn't cut it. So if you go to the polls that we had, what they say to me today was that building the ecosystem in which the ECC is embedded, which means changing roles, changing processes, new ways of thinking, new ways of working with data, those are the capabilities which are harder to develop because they involve more aspects of the company. So things like enterprise architecture expertise, I think, is more difficult. Those are the capabilities. So I would say enterprise architecture expertise is one of the more difficult ones. Data science is expensive, but then having data science people, once you have them, putting that to the business problem is another difficult issue. So in terms of capabilities, and enterprise architecture capability is important, but then since we have the practices, I shouldn't say automatically, but they help to bootstrap they help to bootstrap the capabilities themselves. So it's a complicated process, but it's also an interesting process. It gives you hope that you don't have to stay stuck in one point. If you have something to start with, just get started and then bootstrap.
Thank you. So when we think about not the particular capabilities, but now kind of thinking about the overall change that an organization might need to go through in order to successfully implement ECC. And I don't think you can answer this question literally and specifically, but how much is will and how much is skill? In other words, kind of we're comparing the need to acquire or develop new skills versus just the kind of cultural baggage that an organization might have. Can you put a percent on how much is skill versus will?
I always think that skill, I would say will is a little bit more than 50%. I was going to say 50-50, but I don't think so. It's a little bit more of will. I don't know. I should say it's 60-40, because you see the skill. If you're just talking about data science skills, or if you can acquire the skills, and assuming that you have the resources to acquire some of the skills, you can do that. But changing the will requires changing processes, people's thinking, and even our own, audience today. They said that what they said was changing the will is more difficult, because the first thing that they said was getting people to think differently about data is very important, right? So to me, that says will is a bit more difficult to change than skill. And by will, I don't just mean let's put the money in. That's one part of the will. Top management can say, let's acquire the data science. Let's put in some money and get 5 data scientists and then, do that. But then how do you percolate the changes down and make the changes happen? We came across a couple of applications where the applications were great. There's at least one case where they had an application which was able to predict to 90% accuracy, I think, the probability that somebody would pay their insurance premium. And that never got used because the changes that were needed for people to understand what it was doing and to change the way that they were doing things never happened. So architecture was not done, enterprise architecture was not done, and there was not enough co-creation, so there was no buy-in. It didn't happen. I would say will is more important than skill, but both are important. I mean, I should not say the skill is not important.
Thank you. One of the things that you talked about in the presentation is the need for co-creation, and probably a kind of a larger commitment to co-creation than many organizations are accustomed to. But doesn't kind of ECC in the enterprise need an ultimate owner? And how much variance is there? Kind of where does the buck stop, and how much variance did you see in your research?
Yeah, that's actually a great question, and I think we as we were talking about co-creation among the three of us, we struggled with that. So it's easy to say that co-creation is important in the sense of developing the shared responsibility, but to give you an example of where the buck stops, usually what we saw was the process owner So for example, if the process is, let's say, a sales application process, so the process owner for that application or for that process, the business process, is one of the people, is one of the persons responsible. The way that some organizations handle this issue is they have a steering committee, right? At least, so they have a steering committee where they have senior people from the business domains, the data science lead, and the IT lead. So a steering committee looks at all the ECC applications, because in early stages that's important. Looks at the overall portfolio, tracks the development and the progress of each of them, and then there are periodic. This is what they did. They had periodic reviews to see how each application was faring, who was doing what. So if you could say, if you wanted to know where the buck stopped in a few of these companies that we saw who had a strategy, most companies didn't have a strategy. They didn't have a strategy of co-creation, many of them, and they didn't really think about how to manage the portfolio. But in the ones that did, it was a high-level steering committee which said, this is our portfolio, this is how we look at it over time, this is how we track their progress, this is how we stage gate processes, this is what, if we kill something, we have to kill it at this stage. That kind of mechanism was in place to make sure that the buck stopped somewhere, maybe not with a single person or a single department, but a set of senior people who had the overall view of things.
Thank you. When we're implementing ECC, is efficiency and near-term incremental improvement a good enough end in and of itself, a good enough justification, or do we need to be thinking from the beginning about laying the groundwork for something greater?
I think efficiency, small-term, near-term efficiency goals did drive some of the applications we saw. But the reason why I think that's not, or we thought that was not enough, is because it's a pity to stop there. Because of the fact that processes and practices bootstrap each other, if a company just stops at the first efficiency goal and then says we're done, then they are not really using the generative capabilities of these applications. So, if you've developed an application, you've got a culture of co-creation, you've got, you're starting to think about enterprise architecture, you're starting to think about new roles. Why not use that in a continual way and get the bootstrap going? So while efficiency is a good, we did, as I said, we found a lot of companies where efficiency was a driving, because it is efficient. It can go through humongous amounts of data, come up with consistent inputs, make categorizations and things like that. But stopping there would be, in my mind, a pity, because then you wouldn't be really exploiting the capabilities. It wouldn't get into the woodworks. It would just be in different, it would just be in very isolated places, and then you wouldn't get the returns from the leverage that comes from connecting all of these things together.
Sometimes in organizations, it can be tempting to take a shiny new toy and try to apply it everywhere. So what are some rules of thumb to kind of identify where AI is going to add, or ECC is going to add the most value versus where kind of existing tools or processes are good enough?
So I think in order to, so we typically think of it as a ladder. So for example, if you don't have process, if you don't have documented processes, if you don't have a good, business rules, strong business rules, ECC won't make any sense, because, what are you going to, apply the data to? So a couple of rules there is, you don't have to, you can go through, so analytics, of course, is an important base. If you already have an advanced analytics capabilities, the ECC is a very small step towards that. The checkpoint in my mind are the two expertise, the two capabilities of domain expertise and enterprise architecture. Domain expertise tells you this is what's needed, this is where the problem is, this is where, and so it can say, do I need a learning algorithm, do I need an ECC, or can I just use predictive analytics, can I just use descriptive analytics sometimes? So domain expertise and data science experts get together to understand that. And enterprise architecture tells you, is it possible? Can we have the changes that this is needed? So yeah, it's not necessary that every problem has to be tackled by this shiny new toy, and that was one of the things that we learned. And maybe that's disappointing to some people who want to use the shiny new toys. But there are, in the paper, when the paper comes out, we have a couple of references that, reference some of the past work that we did, which talks about a ladder. And the ladder goes from process discipline to, availability of data, and then descriptive and, analytics, predictive analytics, and then how to get to ECC. So essentially, if you have good data, and if you have a good IT infrastructure which has the data and stuff, and you have good business rules, then you could go up the ladder. But to understand, if to say, okay, I have to use ECC, or it would be nice to use ECC, I think go to the domain experts first and see what they say. Do they understand? Do they know the business process? They know what the pain points are, and then see if you need to stop at if analytics is enough, or do you want to go ECC.
And Monideepa, that brings us to the top of the hour. So thank you so much, and to you and to our audience, and apologies for not getting to all of your terrific questions, but they were overwhelming. Over the next few days, please look out for a feedback survey that we'll send via email, and we greatly appreciate your thoughts and opinions on our program today. A reminder that a recording of this program, along with the slides, will be available within 3 to 4 business days. And that concludes our program. Thank you for attending. Thank you to our speaker, Monideepa Tarafdar, and thanks to our sponsor, Bold 360 by LogMeIn.
Thanks, Paul.